Hello everyone, welcome back to one more session of this IoT course. This is the continuation of 9th session. Already I have demonstrated how we can connect DST level sensor, that is temperature and humidity sensor, with Arduino Uno, and how Arduino Uno can receive sensor data, that is temperature and humidity data, from DST level sensor. But the problem is Arduino Uno does not have any inbuilt Wi-Fi module. That is why I was unable to demonstrate you that how Arduino Uno can transmit data to the cloud, that is ThingSpeak. But in the 9th session, I have demonstrated that NodeMCU can send data to ThingSpeak cloud because of NodeMCU has an inbuilt Wi-Fi SoC, that is called ESP8266. Today I will demonstrate to you how Arduino Uno can transmit sensor data, that is temperature and humidity value, to the ThingSpeak cloud by using ESP8266 Wi-Fi module. Okay, I'll come to agenda. Temperature control of a room using temperature sensor, that is DST level sensor. I will be using Arduino Uno ESP8266 Wi-Fi module and DST level sensor, and also ThingSpeak cloud platform. Temperature and humidity control of a room using DST level sensor. Problem statement. Temperature and humidity control is extremely important in modern industries, especially food industries, laboratory, pharmaceutical industries. Food safety law states that all food products have to be kept at designated temperature if they are going to be safe to eat. Having them too cold renders them inedible, and too warm, and it could encourage bacterial growth. So it is essential to have a temperature monitor to protect the health of consumers. We know excess humidity causes problems such as corrosion and IT equipment failure. Moreover, dryness of the skin directly affects several metabolic functions, including oxygen intake, the shedding of water vapor, salts, heat, etc. So it is very important to keep track of the temperature and humidity not only in offices and labs but also in our home. In this module, we look forward to implement a cheap and effective solution to this problem using a microcontroller.
Recording. Now I will explain different components and I will tell you how to make the circuit for this project. This is NodeMCU or ESP8266 module. This is Arduino Uno. This is DST11 sensor. These are the jumper wires. This is USB cable to connect NodeMCU and the laptop. This is USB cable to connect Arduino and the laptop. This is Arduino Uno board. It is a microcontroller board. This is the microcontroller. This is the microcontroller. Already I told you what is microcontroller. Microcontroller means whenever you have on-chip microprocessor, that is CPU, memory and input-output peripherals, or you can say programmable input output peripherals or pins, then it is called microcontroller. This is the microcontroller. This is ATmega 328 chip, the microcontroller chip. Here you have a microprocessor, you can say 8-bit microprocessor in ATmega 328 chip, 8-bit microprocessor. So now it has also static RAM, EEPROM and the flash memory where you upload the program. So you can see over here there are 14 digital pins, or you can say ports. Among these 14 digital pins, 2 are transmitter and receiver pin. That is, pin number 0 is receiver pin and pin number 1 is transmitter pin. Among 14 pins, 6 pins are PWM pin, pulse width modulation pin, where input is digital but output is variable analog voltage. Okay. After that, I think you can see, guys, 0 to 13 are digital pin. Now after that we have one ground pin, and then after that we have AREF pin, and rest are unused. So now over here we have 6 analog pins, guys, you can see, from A0 to A5. After that we have one V-in pin, then ground pins, then 5-volt pin, then 3.3-volt pin, one reset pin and one IO reference pin. Okay, this is all about the pin, or you can say ports. So now here you can see, guys, the red one, this red button, this is basically the reset pin. You can reset the circuit pressing on this particular pin. This is the crystal, these are the condensers. Here you have many resistors within this board. The board itself is called the printed circuit board. The blue board is called printed circuit board, called PCB. This is the port through which you can connect the USB cable, right? And you can connect to your laptop or computer for uploading program or transferring data. This is crystal. This is the port where you can connect the external power supply or battery. Okay, guys. So I'll tell you one thing, that this input output ports, that is the IO peripherals or pins, you can say, of this microcontroller chip, can communicate all these pins, like the digital pins, the analog pins and all other pins over here. Okay, so this circuit is actually fabricated within this board internally. Okay, so that is the basic understanding of what is Arduino board. This is NodeMCU or ESP8266 module. This is a microcontroller board which has ESP8266 Wi-Fi SoC, that is single on chip. Within this module, there is a processor called LX106, which is a 32-bit RISC processor. Here, already I told you that this board has 17 GPIO pins. So these are the some GPIO pins. This is the port through which you can connect USB cable with this board and your computer or laptop. This is the antenna, that is 2.4 gigahertz, antenna is embedded over here for connecting to your Wi-Fi. So now this is a DST11 sensor that senses temperature and the humidity. Now I will tell you how to make the circuit for this project. First I will take Arduino. I will connect DST11 sensor. This is negative pin, that is ground pin. This is the black one is the positive pin, that is I have to connect to 5 volt of this Arduino board, and third one is the data pin. I will connect it to pin number 4 of Arduino. This is, guys, you can see this is pin number 4. I will connect it, right? This is 7, this is 6, this is 5, and this is 4. This is the middle one, data pin. Now I will connect the black one, that is positive one, to 5 volt. Guys, you can see this is the 5 volt. And now I will connect the ground pin to this pin. Guys, you can see this is ground and the 5 volt. Okay. Now I will connect receiver pin, you can say. So we need one RX, one TX. So we are not using the TX RX pin of this particular Arduino. So we are using PWM pin for receiver and the transmitter. So here the receiver pin is pin number 5 of this Arduino. So I will connect it. And another one is the transmitter pin. I will connect it to pin number 6. So point to be noted. So I have connected one jumper wire in pin number 5 as the receiver, and I have connected another jumper wire in pin number 6. Both are PWM pins. Now Arduino part is over. Now I will connect this receiver pin in D5. So guys, you can see this is the D5 pin, but here D5 pin will be the transmitter pin. If pin number 5 of Arduino is the receiver pin, then the D5 will be the transmitter pin of NodeMCU. Now I will connect this one, that is the transmitter pin, that is transmitter pin of Arduino, that is pin number 6, to D6 pin of NodeMCU, and D6 pin will be the receiver pin of NodeMCU. Okay guys, so we are actually establishing the serial communication. Okay. Now I'll connect this particular jumper wire to the ground pin of Arduino, as you can see, and the ground pin of NodeMCU. Okay guys, this is called common ground. Okay, so this is the circuit diagram. So now I'll connect USB cable to this Arduino, and this part of this USB cable I'll connect to my laptop, and now I'll connect this USB cable to NodeMCU, and this part of the cable I'll connect to my laptop, right? So this is all about the circuit diagram, as you can see. All about the circuit diagram.
Guys, I will now extend the code. Guys, you can see from here, this is the code, right, for transmitting data from Arduino Uno to NodeMCU, or you can say ESP8266 module. So we are using serial communication. Guys, you can know about the serial communication by using the serial port. Okay, so this is the code. So what you have to do, you have to install certain libraries, right? Library like Arduino JSON library for this communication. Then you may ask, so what is JSON? JSON is basically a file format, or you can say the data exchange format by which you can transmit data, or you can store data in human readable text. Okay, that is the JSON. So that is why you have to include the JSON library and you have to use it. Okay, so we are also using another library called software serial.h. Why we need this library? Because we establish the serial communication, right? So already I told you we will use serial communication to transmit data and the receive data. Okay. So first, what I will do, I will go to tools and go to manage libraries. Please wait. And you have to include or install Arduino JSON library from here. Please wait. Just type Arduino JSON. Guys, you can see, just have to scroll a little bit. Right. You can see, guys, this is the Arduino JSON. There are a lot of versions over here, just you can select, but we are using latest Arduino JSON version, that is 6.18.3. Guys, you can see here it's written install. But what you have to do, you have to select the version, then you click on install to install this library into this Arduino ID, or you can say in Arduino folder. Now I'll explain the code. As you can see, this is the software serial NodeMCU 5 and 6. So here the 5 is receiver pin and 6 is transmitter pin. Okay, here is 5 is receiver and the 6 is transmitter. Okay, so but point to be noted that if we use 5 as receiver pin for Arduino, and then in NodeMCU it should be D5 should be the transmitter. If in this Arduino 6 is transmitter pin, in NodeMCU D6 should be the receiver pin. So it should be crossed. Okay. So this is the initialization of serial port like 5 and 6. One is the receiver pin and another is the transmitter. 5 is receiver and 6 is transmitter. So now initialization of DSP11 sensor. As you can see here, the DSP data pin we have used the pin number 4. Okay, so we have declared two variables. One is the temperature and the humidity, temp and hum. So also we have initialized the baud rate is 9600. Already I told about the what is serial dot begin. So also we have initialized the NodeMCU dot begin as 9600, and we have inserted one delay of 5000 milliseconds. Now this is a loop function. The previous one, that is the setup function, where we initialize the baud rate. Okay. Now we have the loop function. Here we have the static JSON document. So if you use static JSON buffer, so then you have to use the JSON library 15.xyz, right? But we have used JSON document, that's why you can use the 16.xyz version of JSON library. So this is the object of size 1000. The name is, the object name is doc. So here I called the DSP11 function. So I have written one ISO11 function to read the, as you can see here. Here in this function, this is read function and DSP dot read humidity and DSP dot read temperature. Guys, you can see. Okay. So we are also printing over here, but here, so after calling this function, okay, assign after calling this function, assign collected data to JSON object. As you can see, hum is assigned to JSON object humidity, and temp is assigned to JSON object temperature. Then the serialization, like serialize JSON object and then node. Why we are doing serialization? Serialization is basically the process of reading data from serial for serial communication. I repeat once more. Serialization is nothing but a sending data to the serial port. Okay. So in this case, that is for Arduino, we are sending data to the serial port, and that is basically the serialization. So now in this particular port, so data, that means temperature meter actually sent to the serial port, where we have the JSON update. Okay, send data to NodeMCU. This is all about the Arduino code, guys. Now we'll open the NodeMCU code. This is the NodeMCU code, guys. Already I told you that how you can connect Wi-Fi module, or how you can connect Wi-Fi, how you can include Wi-Fi client library, and then ESP8266 library and the ThingSpeak library. Already I have discussed in last session. So here I have included once again software serial for establishing serial communication, because NodeMCU will receive the data from the serial port, that is called deserialization. Okay, and I have already added the Arduino JSON library. Okay, you have to include this one. So after that, I've given the SSID of my Wi-Fi router, right, and the password also. Right, this is my channel ID and the API. Already I discussed in previous. So this is the temperature humidity variable. So this is the initialization of the port. One is the transmitter, one is the receiver. Already I told you. So now I'll come to this. So guys, you can see this is setup function. Serial begin is 9600. Already you have seen in Arduino, that is also 9600. This must be same. This is the NodeMCU begin also 9600. This initialize serial port. Okay. So then we have used the Wi-Fi connection establishment port. Okay. So as you can see already I have explained in our earlier session, but you have to give username and the password. As you can see, already explained earlier. So this is the deserialization. That means deserialization means the NodeMCU will receive the data from the serial port. Okay, that process is called the deserialization. Already I have created one static JSON document object of the same size and the same name. So as you can see, the name is same, this is block, and size is 1000. Already I have discussed while I was discussing about the Arduino code that the size is 1000 and the name is block. And this is the deserialization means that means if NodeMCU is receiving the data from the serial port, and that process is called the deserialization. So serialization means the Arduino is sending the data to the serial port, that is called serialization, and NodeMCU is receiving the data from the serial port, that is basically deserialization. Here the object is block. If there is an error, since it is not receiving data, is there any kind of error, it will show the invalid until it will receive the correct data. It will continue and it will display invalid data or invalid JSON object. So as you can see the after receiving the data, humidity object JSON object is copied to new variable and print the value, and then temperature JSON object, that is block temperature, is copied to temperature variable and print this. After that, as you can see, the ThingSpeak upload function, that is ThingSpeak.write field. So here you have to give the channel number, field number 1 the temperature, and the channel API, write API. So for field number 2 means the humidity, and also it means write API, the channel number. So that's it. The code is over. So now I'll execute the code. Now I'll execute the code. First I'll execute the Arduino code, and this is the ThingSpeak. Okay. So now I'll first execute the Arduino code, then I'll execute the NodeMCU. As you can see, this is the Arduino code. So I'll select the board from tools. This is the COM port 8 Arduino Uno. Now click on compile and upload. Wait a minute. Compilation done, uploading also done. Go to serial monitor. Wait. As you can see, program started. Humidity is 52 and temperature is 27 degrees centigrade. This is my room temperature and the humidity. Now I'll cross it. Go to NodeMCU port and execute. First I'll select the board from tools. This is NodeMCU 1.0 ESP8266 module. Tools once more, select the port. As you can see, the port is COM port 5 because COM port is assigned to Arduino Uno. Now click on compile and upload. Guys, already I told you that Arduino Uno does not have inbuilt Wi-Fi module. That's why we are using ESP8266 module for transmitting data. Whenever you want to connect Arduino with the cloud, we have to have some extra Wi-Fi module or any other wireless module to communicate with internet or cloud, whatever you want. Uploading is going on. Done uploading. And compilation successful and also uploading successful. Click on serial monitor. As you can see, this one object received and the temperature and humidity value, humidity 59 and temperature 20. So now we'll open the cloud. As you can see, the data last entry less than a minute ago. So guys, just a minute, I'll show the data value to you. This is the data value. As you can see, this is 31st July. So this is the value. As you can see, 20 dB. Okay. As you can see, the humidity value. The date is 31st July 2021. Okay. Time is 13. Time is 15:45. Okay. As you can see, this is the recent value. Now, if you want to download the data, go to data input and export. And that you can see, you can use it for different purposes.
That's it for today. Thank you very much.